400 million miles from Earth, a small moon orbits a giant planet, Jupiter, which is a gas giant with swirling clouds. This moon, Europa, is one of Jupiter's 4 largest moons, discovered by Galileo Galilei in 1610. Its surface is frozen, silent, and appears lifeless, predominantly white with tan cracks and streaks. However, beneath this icy exterior, something profound stirs, hinting at hidden activity. They call it Europa, and it might be the only other place in our solar system where the ocean still remembers how to breathe, holding more water than all of Earth's oceans combined. Europa was first photographed by Voyager 1 in 1979, revealing a cracked, glowing shell that reflected sunlight like glass, indicating a young and active geological surface. Later missions, like Galileo and Hubble, confirmed something extraordinary. Beneath that ice is a global ocean, a vast body of liquid water hidden from direct view. This isn't just a few pockets of water, but a sea stretching over 60 miles deep, containing more liquid water than all of Earth's oceans combined, making it a prime candidate for harboring life. Beneath miles of frozen crust, this immense ocean moves, slowly and rhythmically, like a living thing, constantly being flexed and stretched by Jupiter's gravity. Scientists believe tidal forces from Jupiter's immense gravity flex Europa's core, generating significant heat beneath the ice through a process known as tidal heating. This internal heat melts the water below and causes cracks to open and close on the surface, allowing plumes of water vapor to shoot into space, a dramatic display of geological activity. When the Hubble Space Telescope pointed at Europa, it captured those plumes, towering an astonishing 120 miles, or 200 kilometers, high, providing direct evidence of the subsurface ocean. It was as if the moon was breathing, in silence, through frozen lungs, and with each exhale, it sent pieces of itself out into the dark, offering a glimpse into its hidden depths. Deep under that ice, in total darkness, life could exist, not necessarily like us, but as it does on Earth's ocean floors, adapted to extreme conditions. At the bottom of our own seas, where sunlight never reaches, life thrives around hydrothermal vents, feeding on heat and chemicals, demonstrating life's adaptability. If those same conditions exist on Europa, and every measurement from missions like Galileo and Hubble says they do, then something could already be swimming there, sustained by similar energy sources. This is not a dream, but a scientific probability, supported by the presence of liquid water, essential chemical elements like carbon, hydrogen, and nitrogen, and internal energy sources. Europa's ocean is also likely in direct contact with warm rock at the seafloor, providing hydrogen and other chemicals, which could fuel chemosynthetic life forms. When the Galileo probe passed Europa in the late 1990s, its instruments picked up faint electromagnetic signals, patterns too structured to be random, hinting at unusual activity. NASA called them plasma waves, but some of the patterns repeated like echoes, suggesting a consistent and perhaps deliberate source beneath the moon's surface. When those recordings were converted into sound, they resembled the rhythm of sonar, as if something below was listening or communicating in a way we don't yet understand. No one could explain it. No natural source matched the sequence, and still, it continued, each time Galileo passed overhead, leaving scientists with an enduring mystery. In the 2030s, NASA will send a new mission, Europa Clipper, launched on October 14, 2024, to orbit Jupiter and dive close to Europa's surface, traveling 1.8 billion miles to reach its destination by April 2030. It will sample water plumes, searching for organic compounds and biosignatures, and maybe something alive, using its 9 science instruments to investigate Europa's habitability. But it won't land, because landing means breaking through the thick ice, and what's below that ice is something we've only imagined, a world yet to be explored directly. If we disturb it, what if it looks back? This profound question fuels our cautious approach to exploring Europa, acknowledging the potential for unknown life. Some scientists theorize Europa could host a biosphere, a self-contained ocean world, home to bioluminescent creatures, or even intelligent life evolved in isolation for billions of years. Others believe it's sterile, a frozen wasteland. But when you look at the intricate cracks on its surface, They visually resemble veins, suggesting a deeper organic structure. When you measure its seismic patterns, they resemble a heartbeat, a rhythmic pulse that suggests Europa is alive, whether in biology or in the memory of its dynamic geological processes. We look to Europa to find life, to understand our place in the universe, but maybe it's looking back to remind us what life really is in its most fundamental forms. A flicker of warmth in the dark, a breath under the ice, a voice we've only begun to hear, echoing from the depths of a distant ocean world. This is truth in the shadows, where the universe whispers its secrets, and the ocean listens, holding untold mysteries beneath its icy veil.